In our example of number 4, related to marginal rate of substitution, let's find out the marginal rate of substitution for a numerical CES utility function, which our function is, the utility is a function of x and y and is equal to 0.5 x to the power of 0.3 plus 0.25 y to the power of 0.3 whole to the power of 1 over 0.3. From the general format of CES utility function, we know that our rho is equal to 0.3. This 0.3, this one, and this one. Rho is equal to 0.3. And A, which is the coefficient of x, is equal to 0.5. And B, which is the coefficient of y, is equal to 0.25. So now, the marginal rate of substitution for this CES utility function is equal to the marginal utility of x divided by the marginal utility of y, and is equal to, we know that the marginal utility of x is equal to the partial derivative of this utility function with respect to x, and the marginal utility of y is equal to the partial derivative of this utility function with respect to y. So now let's find out the value of marginal rate of substitution for the CES utility function. So let's go, guys. So first of all, let's find out the partial derivative of utility function with respect to x. So it's equal to 1 over 0.3 multiplied by 0.5 x to the power of 0.3 plus 0.25 y to the power of 0.3 whole to the power of 1 divided by 0.3 minus 1 multiplied by, now let's take the derivative of the inside function with respect to x. So here we do not have any x, so the partial derivative of this one with respect to x will be equal to 0. So now the derivative of this part with respect to x is equal to 0.3 multiplied by 0.5 x to the power of 0.3 minus 1. 0.3 minus 1. So similar, the partial derivative of utility function with respect to y is equal to 1 divided by 0.3 multiplied by 0.5 x to the power of 0.3 plus 0.25 y to the power of 0.3 whole to the power of 1 divided by 0.3 minus 1 multiplied by, so now the derivative of this inside utility function this time with respect to y. So the derivative of this part with respect to y is equal to 0. The derivative of this part with respect to y is equal to 0.3 multiplied by 0.25 multiplied by y to the power of 0.3 minus 1. So now we have some common term that cancel out this one. So this one will cancel out with this part. This 0.3 will cancel out with this 0.3. So this whole term will cancel out with this whole term. So we will move to marginal rate of substitution is equal to 0.5 multiplied by x to the power of 0.3 minus 1 divided by 0.25 y to the power of 0.3 minus 1. So 0.5 divided by 0.25, so it will be equal to 2. Then x to the power of 0.3 minus 1, it will be equal to x to the power of minus 0.7. Then y to the power of 0.3 minus 1 will be equal to y to the power of minus 0.7. So finally is equal to 2 multiplied by y divided by x. So we move y to the here and x to here. So then the power will change to positive 0.7. So finally, the marginal rate of substitution for this CES utility function MRS is equal to 2 multiplied by y divided by x to the power of 0.7. So this is the marginal rate of substitution for this CES utility function. As we said already in the last video, when we find out the marginal rate of substitution for the CES utility function, we said that the marginal rate of substitution for CES utility function depends on how much or how many X and Y we already have in our consumption bundle. So as you see here again, so we have in this marginal rate of substitution value Y and X. This 2 comes from the division of this coefficient of X to coefficients of Y. And this 0.7 will comes to this one, rho minus 1. So again, we have Y divided by X. So if we have different value for Y and X, so we have different value for marginal rate of substitution. Why? Because the indifference curve for CES utility function is not linear. So when we have a non-linear function, then the marginal rate of substitution will be different at different point of the indifference curve. So this is a numerical example for marginal rate of substitution for a CES utility function. So hope now you clearly understand how we can find out the marginal rate of substitution for a CES utility function. I will see you guys in the next video that we are going to solve another questions related to another type of utility function to see what will be the value of marginal rate of substitution. Till next time, see you guys again. Please subscribe my YouTube channel and hit that like button and share to other guys in order to enjoy it together. See you next time.